Okay. So for the first one, just get my normal CDF, inverse norm, z-scores, and so forth. So the length of the pregnancy is 200 days. Okay, 200 days and a standard deviation of 3.5. Note that I provide a normal curve just for reference. Okay, and watch this. If I say use technology, I want you to use normal CDF inverse norm. Okay, even if you think, oh, I can just draw my curve like we started off with, technology means calculator. What proportion or percentage of lasts more than 204 days? Okay, so here it's percentage, asking for percentage, more than 204. So 204 is your lower limit, and this is just a large number. Okay, and you've got 200 and 3.5, and we multiply that by 100, and so our answer there is 12.65% of pregnancies. Okay, last longer than that. Only 10% of Hippo pregnancies last less than this many days. So where does the line go, right? So first of all, I would say maybe trial and error sometimes, but I would say it's over here because we're told that 10% lasts less than it, so it just makes sense. This is always less here towards the left. So you have 10% to the left of the value you're interested in. So it wouldn't make sense to have it over here because this is way over 50%, right? If you had the line here. So 10% is right there. So we would use inverse norm, 0.1, and you just type in the mean and the standard deviation. And that gives you 195.51 days. There we go. Only 20% of pregnancies last longer than this many days. So you're thinking somewhere over here, and the 20% is given, which is to the right of the value you're trying to find, which means this is 80%. So you get 1 mark for the 80, and then you'll get another mark for actually doing inverse norm. Morning. And this will give you 202.95 days. If I asked you for the z-score, what would you do here if I asked you what's the z-score of 20% of pregnancies being greater than this value? You have 2 choices at this point. You could use this formula, right? Or inverse norm, 0.8, but what would you put in here? 0.1, right? So this is just an aside. If I asked you for the z-score, you could do it that way. Sometimes there's, quite often actually, there's more than one way to get to the answer. Right, what happened there? This is, yeah. The middle 70% of hippos of pregnancies last between this and this many days. So the middle, you literally go to the middle, and you know that that's 70% that we're talking about, which means that 30% needs to be split between these 2 sections. So this is 15, and this is 15. Okay. So you got to do 2 inverse norms here. To get the first one right here, you would use 0.15 and 200, 3.5. Okay. To get the second question mark here, you do another inverse norm. In this case, it's 15% and 70%. That adds up to 85%. So you go 0.85, 200, 3.5. And so now we're going to get those days. We use our calculator, and so we get 196.37 days. And the other one is 203.63 days. Okay. So that is, so 70% of pregnancies are between these 2 values here, okay? The middle 70 days. So 1 mark for each entry. So that makes this page worth 8 marks. No, wait, 1, 2, 3, 4, 5, 6. Yeah, 6 marks. 6 marks, not 8. Then we do the back side. So same idea here. The poison dart frogs are normally distributed with a mean of 20, standard deviation of 0.7 millimeters, so very small. They're very small. I don't know if you've ever seen them or watched a documentary on them. So calculate the z-score for that frog. So to figure out the z-score, we can use the actual value minus the mean, okay, divided by 0.7. So that'd be 1 divided by 0.7. We know that the z-score is supposed to be positive, correct? Because if this is your mean, right, if the 20 is here, this would be what? 20 plus 7, this would be 20.7. This would be 21.4 right here. So 21 is somewhere in here, okay? That's where the 21 is. So we know we're above the mean, so we're expecting this to be 1 point something positive, right? 43, that is. So if you have that, you get the mark. Could you have used inverse norm here? In this case, inverse norm is not useful because you don't know percentages, right? Inverse norm only works if you would know some percentage to the left of it. So you couldn't use that. Explain what it means. So this is where the second mark is going to come in. Explain what this means, okay? A frog measuring 21 millimeters is 1.43 standard deviations above the mean. Okay, so that's your second mark there for explaining that property. Okay. B, a different poison dart frog is 20.47 millimeters long. What percentage of frogs would we expect to be shorter? Okay, so it's asking for percentage, so you got to use this one. And we want something that's shorter than this. So we have to use a very small number for our left limit, and we stop at 20.47. This is 20 and 0.7. And we multiply that by 100 if we want percentage. That is a 0.749 times 100, so that's 74.9% of frogs are expected to be shorter than that. What percentage of frogs are shorter than this or longer than that? There are two methods. I will give you the mark if you used either one. Okay, but the idea here is 20.1. If you go back here, 20.1 is right about there. So it's kind of saying, right, we want 20.1 is right here. Can you see that? 20.1, and 22 would be somewhere over here. Okay. So we kind of want to know the this and this, right? So frogs that are shorter than this or longer than that, that's what we want to know. So method 1 would be 1 minus normal CDF of 20.1, 22, 20, 0.7. So that's 1 minus 0.4424, which ends up being 74 point, sorry, I should first do the decimal, right? Because I'm with decimals here, 0.749. Okay, or 74.9%. Okay. Method number 2 is simply figuring out this and adding it up, right? So it would be normal CDF of negative 1,000 or 10,000, 20.1, 20, 0.7, and normal CDF of 22 all the way to, let's say, 10,000, 20, 0.7. Okay. You figure out this end and this. So this would be A and this would be B. Right? So you're figuring out A and B separately, and then you're going to add them up. I'm afraid to say that I don't have the answer to this. So if you have, it's still going to be 74.9, correct? Has anybody done this and gotten a different answer? Different answer? Way different? So is my answer wrong, maybe? Let me, I was doing so good. Oh, I looked at a different 5576, right? I should have caught it totally. I was wondering if I take off 0.44, how do I have 74.9? Sorry, I was looking at the wrong, I was looking at this one. My bad. On Fridays, you got to be extra careful. Okay. Must have been the Jets game. My bad. 55.76. So regardless, if you do it this way, you should still get that, or very close. Okay? So you get the mark regardless of which method you use. Actually, this is 2 marks. Sorry. I should say, like, something like this is definitely worth 2 marks, because you have to go this step of subtracting is 1 mark, and actually finding this part is another mark. Regardless of which method you choose, you get 1 mark. So sorry, I'm going to change this to 1, so you're not thinking it's 3, right? 1 for this step, subtracting, and 1 for finding the normal CDF. Or you can say 1 and 1 here, and obviously you have to add them up to get the final answer. Okay. If one would consider the population of 5,500 frogs, how many would be shorter than this or longer than that? This is based on the previous question. So you just go 0.5576 and you just multiply it by the number of frogs. And that gives you 3,066.8. And when it's asking how many frogs, you need to round, right? So it'd be 3,066 or 3,067 frogs. When you're doing the mean standard deviation, it's okay to have decimals. Okay. This is the one I didn't show you yet. So I'm just going to leave it for now. Just put a little star. I don't want you to cross it out. I want you to say later. So if I hand this back and you've watched me do this in the lesson, then you can still give it a try at one point. I'm just going to leave that for now.